All right, here is the back of part 3 of your review. So we are looking for the length of AC, which is this whole thing. This may or may not be a special right triangle. I don't know, don't have enough information, but for that, can totally do this using geometric mean. So I could call the whole thing x, but I'm just going to call this right here x, because if I can find x, then I can find the length of AC. So if that's x, this whole thing is x plus 5. So this is a leg squared, 10 squared, is equal to the piece that's attached to it, which is 5, times the whole thing, which is x plus 5. So this is going to give me 100 equals 5x plus 25. So 75 equals 5x. So x equals 15, which means when I plug that in right here, and I'm looking for the length of AC, that's the whole thing, so the length of AC equals 20. All right, so Lynn wants to build a triangular vegetable bed with sides 7 feet, 8 feet, and 10 feet. Which of the following best describes the vegetable garden? All right, so I've got this vegetable garden, which is 7, 8, and 10. My choices are cute, obtuse, right, he cannot form a triangle. Well, if you can't form a triangle, let's check that one first. 7 plus 8 is 15, that's greater than 10, so 8 and 10. So if you check each one, every 2 sides that you add has to be greater than the third, so we can definitely form a triangle, so the answer is not D. Which means I got to figure out if it's acute, obtuse, or right. So I plug it in to 7 squared plus 8 squared, blank with a question mark, 10 squared. So this is going to be 49 plus 64 and 100. So that's going to be 113. That is greater than 100. If a squared plus b squared is greater than c squared, then it is an acute triangle. All right, Don's school has a rectangular lawn with the dimensions shown. Students often walk along the diagonal of the lawn as a shortcut. How much shorter is it to walk directly from J to L rather than from J to K to L? All right, well, if it's a rectangle, if this is 6, this is 6. This is right, so I'm going to call this x. So I'm going to first find that, so that's going to be 6 squared plus 16 squared equals x squared. So 36 plus 256 equals x squared. So that's going to give me 292 equals x squared. So x is equal to the square root of 292. All right, so 292, I can divide that by 4. It's going to give me 4 and 73. 73 is a prime number. So x is equal to 2 square root of 73. All right, so that's what this length is. So it's shorter to walk that length, but it says how much shorter. So I need to take this total distance here and subtract that. So 16 and 6 is 22. So that would be 22 meters. And then I'm going to have to subtract from that 2 square root of 3 meters. Can't actually subtract. Square root of 3, not square root of 3. Goodness. Hang on. My board will cooperate in a second. There we go. 2 square root of 73. And I can't actually subtract those because there's a square root on it, so I put it in parentheses, meters. That's it. And of course, this is your exact answer. If you wanted to actually know what it was, then you would have to calculate the decimal, but we are not worried about that right now. All right, so here, if the length of xy is 2, what is the length of YW? I totally put an X there. That would be a 2, like I said. And I'm looking for YW, that will be X. Now, you can treat this as geometric mean. You don't really have enough information to do geometric mean, but this clearly is a special right triangle. It's actually a couple of them, because this big triangle here is a right triangle. So if this is 90, that's 60, this is 30. And then if in this little right triangle here, this is 60, this is 30, it means this is 60 here. Okay, so you can separate and redraw these if you want to. Some people feel way more comfortable with that. That is up to you. Just make sure you don't get all your little labels mixed up. In this left-hand triangle here, this is 30, so across from this is S, this is 2S, and this is S times the square root of 3. Okay? Which means that S is equal to 1. So S is 1, which makes this piece right here just the square root of 3. Now, in this triangle over here, this is not S squared of 3 because this is 30, which makes this S, this 2S, and this S squared of 3. So if this is S, all I really want is this right here. So I take that and multiply it by 2. So X is equal to 2 square root of 3. Of course, you did not have to do it that way because I have this big triangle here. Because this is 60 and this is 30, if you just looked at the big triangle and thought about, let's see, we were given that this is 2. We're looking for X. If you just look at the big triangle, this is S, this is 2S, and this is S square root of 3. So S is 2, X is 2 square root of 3. So I did it this way first because I think a lot of people probably would have, and I wanted you to see that it worked that way. But just because there's an altitude there does not mean that you need to use it if you understand the triangle differently. Okay, so then on this one, I'm looking for the perimeter of the triangle. So this is a 45, 45, 90 triangle, so L squared of 2. So if this is 8, this is 8, this is 8 squared of 2. Perimeter means I add them all up, so 8 plus 8 plus 8 squared root of 2 does not give me 24 squared root of 2. Some of you need to seriously think about those things because you keep making the same mistakes. You can't combine this. This is like 8x, so this is going to give me 16 plus 8 squared root of 2. I can't do anything else with that, whatever the units are. Okay. All right. Next one. So line segment AC, if it goes from a vertex to the midpoint of the opposite side, that does not necessarily make it an altitude. It could, but the altitude will always be perpendicular, so it's not that. It could bisect the angle, but you don't know that, but you do know it bisects the side. Even though it bisects the side, it is not necessarily a perpendicular bisector, and you can't just go by the way it looks. I know it doesn't look like it, but even if it looked like it, you may not necessarily know that. This is a median. A median goes from the vertex to the midpoint of the opposite side. That's what a median is. Then we look at GP. Now again, be careful just looking at it the way, going by the way it looks, because I know it doesn't look like it bisects it, but it very well could be a perpendicular bisector, but you don't know that, so we don't know that it bisects it. We don't know that it goes to the midpoint of the opposite side. That's what a median is. Could bisect that angle, we don't know. It is an altitude. The altitude is the height. It goes from the vertex perpendicular to the opposite side. Altitude. Got to know your vocabulary. Now this is the question straight off the last CBA. Quite a few of you missed, because there's a little extra information in here. It says the measure of angle JMP, this right here is 5y plus 12. And JK is 8x minus 30, and LK is 3x plus 20. We want to find the length of LK if PK is a median. So PK is a median, which means it goes from the vertex to the midpoint of the opposite side, which makes these congruent. Now I am looking for the length of LK, which is 3x plus 20 right now. So it means I need x. I do not care about y. Not only do I not care about y, I don't have enough information to figure out y, so it means absolutely nothing. Plus it's an angle measure when compared to my side lengths. These two pieces, since this is a median, are congruent to each other. So 8x minus 30 equals 3x plus 20. So 5x equals 50 and x equals 10. Don't go circling A over there because nobody asked us for x. They asked us for LK, so I got to plug it back in. So 3 times 10 plus 20. That's 30 plus 20, that is 50. Um, 18 looks very much like a multiple choice question. However, there are multiple correct answers here. Now, in this triangle, if this line is parallel to this base, one of the things we learned, let's just think about what we know before we start looking at our answer choices. We have a theorem that tells us that basically our little proportions are set up. So this side over this side equals this side over this side. That is a true statement. And that's kind of looking at it as one triangle with a line through it. But if you look at this as two separate triangles, you got SYT and then the bigger triangle here. These are similar by angle because they share this angle. These lines are parallel, so these angles are congruent right there. So you got similar triangles. So also SY over SD equals ST over SU and things like that. So let's just think about that. Let's go over here and see what's happening in our answer choices. All right, so first one, SY over ST. So SY over ST equals YD over TU. So would that give you the same thing? So SY over ST equals YD over TU. If you're not sure, here's how you can look at this. We know for sure that SY over YD is equal to ST over TU. We know that from that theorem. This piece over this piece equals this piece over this piece. That's what I just wrote down right here. Not every single proportion has to be written exactly like this to have the exact same meaning. When I take this that I know is true, okay, and I could look and see, are any of these actually up there? Let's see, that would be this one right here, SY over YD. So we know that this one works, so we don't have to overthink it when we get there. But when I cross multiply, I'm going to multiply SY times TU and ST times YD. So when I look here, I'm doing SY times TU, SY times TU, ST times YD, ST times YD. So it's the same relationship, it's just a different way to set up the proportion, so this one works also. Okay? And then I can look, now just because something doesn't work exactly like this one doesn't mean that it doesn't work either, but we can see if any of the other ones match up. So SY times TU, no, this is SY times TU, and then YD times TS, it's the same thing, right? YS times TU, YS times TU, DY times TS, DY times TS. So this one works as well. Then, let's see, SY times TU, SU times SD. That's using totally different letters. I don't want to mark it out yet. SY times TU. So the other ones just don't use those. So maybe they work, maybe they don't. So that helps us with those. Now let's look at the rest of these. SY over SD. So this is saying SY, this piece, or this side of the little triangle, over SD, the whole thing. SY over SD equals ST over SU. So that totally works from similar triangles. The side of the little one over the corresponding side of the big one equals the side of the little one over the corresponding side of the big one. So I like C. So then let's look at D. SY over YD equals ST over SU. Now that one, I don't think so, because I got the piece over piece equals the piece over the whole thing. That is not a consistent proportion. I don't like D. Then I'm going to look at E. SU, the whole thing, over TU, the bottom piece, equals SY, the top piece, over SD, the whole thing. Again, we're not consistent. We've got whole thing over little piece, other little piece over whole thing. That one totally does not work. So 4 of those 6 were valid. And that concludes your reviews.